I'll be sharing my slides. Please give me a few minutes. Okay. Let me make it full screen. Okay. So again, thank you for the introduction. My name is Sheila Tobing, and I'm from the graduate program in Energy Systems Engineering at Universitas Indonesia. And today I will be giving, I hope, a short presentation, and it will be an introduction, an overview, and later on Dr. Indra will be giving a more technical information about materials for hydrogen. So the title of my sessions or presentations this afternoon is the Hydrogen Ecosystem, Unlocking Clean Energy Potential in Indonesia. So the outline for today's talk will be something like this, a little bit about the background or introductions, and hydrogen's role in achieving net zero emission, hydrogen as energy carrier, the different types of hydrogen, the supply pathways, and the challenges and opportunities in producing and also implementing hydrogen ecosystem, and then the roadmap in Indonesia, as well as the different hydrogen projects in Indonesia, before we end it with summary. Okay, so a little bit about why we need to use hydrogen is based on satellite measurement that this year from January to October, the average temperature anomaly is 1.28 degrees Celsius above the mean temperature between January to October of 1901 until 2000. So it is measured, and I think it's common facts that almost all of us know. And another report also based on satellite predicted that this year will be the hottest year on the record, with a global average temperature exceeding the 1.5 degree limit above the pre-industrial average. So this one is even higher than the previous data from NOAA. So I did mention about this 1.5 degree limit, and this limit is based on the study and the special report done by IPCC. And this report basically describes the necessary steps to keep global warming at 1.5 degrees Celsius above pre-industrial levels. And why is 1.5 degrees so important? It can refer to the picture on the right. On the left column is the direct impacts of having global warming. And then you have column, this is what happens if we have a temperature increase of 1.5 degrees. And the next one will be the damages if we have 2 degree increase. And we can see that for all direct impacts, that if we have 2 degrees Celsius increase, then the damages to environment is much worse than having it at 1.5 degree. So 1.5 degree is the limit that we can still live on, even though we still have damages to the environment. And now we know about this limit and how crucial is this limit. Now the next question will be, how do we keep the global temperature increase at 1.5 degree? And the answer to that is to achieve net zero emissions. And in order to achieve net zero emissions, hydrogen is crucial. So clean hydrogen, especially clean hydrogen, supports deep decarbonization in many industries. And with the combination of using hydrogen and also renewable energy sources, as well as improving energy efficiency in terms of conversion, then we can achieve net zero emissions. Hydrogen is crucial in energy system integration because of many reasons. One is that we can use hydrogen to decarbonize all sectors. So transportation, residentials, industrials, and also commercial sectors. And then in terms of large-scale energy storage, hydrogen can store larger amounts of energy per unit volume compared to other options like pump storage or compressed air. And also with hydrogen, we can improve the flexibility of power systems because then we can accommodate intraday and interseasonal variations. As I mentioned that we can use hydrogen in all sectors because there are so many applications of hydrogen. Let's say in industrial sector, we can use hydrogen as feedstock for steel and also to produce fertilizer. And then in terms of transportation, we can use hydrogen as a fuel for different vehicles, passenger vehicles, heavy-duty trucks, trains, and even aircraft. Or for heating, we can use hydrogen for heating residential buildings and also to provide industrial heating. Now, I did mention about achieving net zero emission, and most people or most countries set a target of achieving net zero emission by 2050. And different countries, different institutions have their own strategies to achieve this. So this is just one of them from Berkeley National Lab. It mentions that to achieve net zero emission at 2050, then we have to do these 8 strategies by 2030. And you can see that hydrogen is involved in at least 3 of them. Number 4, which is to increase zero emission vehicles. And then number 5, to provide heating. And then number 7, as a carbon neutral fuel, and also number 8. So with one of these example of strategies in achieving net zero emission, you can see that hydrogen is used in more than one strategies or many strategies. Okay. Now the next part is hydrogen as energy carrier, and this is sometimes confusing because in the literature, you can find people who use terms of energy carrier, while others use a mix between hydrogen as fuel and also hydrogen as energy carrier. But I think in terms of definition, it is more suitable to categorize hydrogen as energy carrier. Because a fuel is typically primary energy sources like coal or oil that you can use immediately in engines or turbines. But an energy carrier is a medium that transfers energy from its production source to its point of use. And hydrogen doesn't naturally exist in large quantities in its pure form, and you have to produce it using energy input, and this energy input can come from many sources like fossil fuels, renewable sources, or nuclear. And I did mention about the many different energy sources that you can use to produce hydrogen. And here comes the rainbow of hydrogen, or the different types of hydrogen. You can see here that you have brown and black hydrogen if you use coal to produce it. And then if you use natural gas, you get gray hydrogen. Or if you use renewable sources like wind or solar, then you get green hydrogen. This next slide explains in more detail about this color code of hydrogen. For example, black and brown hydrogen is when you use black or brown coal to produce the hydrogen, and the byproduct of the process is you get CO2 emissions. And you can also read about the other hydrogen. For example, red, pink, and purple are both used to describe hydrogen being produced using nuclear energy. And the next one will be about hydrogen supply pathway. So how do you get hydrogen? And again, different institutions, different scientists have their own idea about this, have different terms. So I'm just taking one of them as examples. For this one, there are three main supply pathways of hydrogen. The first one is power to gas, which is the gray color one. And then power to power, which is the green one. And then gas to gas, which is the blue one. And you can see there are four different sections. You have power grid, energy conversion system, gas grid, and application, which is the sectors that we apply hydrogen for. And you can see that different pathways use different energy conversion system. Let's see this one, gas to gas, is using SMR, which is steam methane reforming, or power to power, we use electrolysis. And the next two slides, you can read in more detail about these three pathways. So power to gas, basically you use electricity to produce hydrogen through electrolysis. And then the result, which is hydrogen, can be processed further to produce methane. And then later on you can store it or use it according to the applications. And then you have the second pathways, which is power to power. So we use electricity to produce hydrogen through electrolysis. And then we use this hydrogen to again produce electricity. So we re-electrify this hydrogen using fuel cell or hydrogen gas turbine. So this is where you have fuel cell electric vehicles. And then the last pathways will be gas to gas, where we use steam methane reforming, which is the most well-established method to produce hydrogen. So we produce hydrogen from another gas, which is natural gas. And in the world, most of our hydrogen comes from this pathway, which is gas to gas. Around 95% of global hydrogen is coming from natural gas and through SMR, steam methane reforming. And what are the challenges and opportunities? And you can see from this picture, it's actually tables, but I cropped it from this journal, so it becomes picture now. The challenges and opportunities in producing hydrogen depends on the method to produce it. So for example, over here you have SMR and then electrolysis. And you can see the critical challenges, the major R&D needs, opportunities, and present status. Let's say we focus on electrolysis. You can see that there are many challenges like high capital costs and then expensive catalysts, because most PEM proton exchange membrane fuel cell use platinum, which is rare and expensive. And because of these critical challenges, then we need R&D in terms of how to get durable and cheap or cheaper materials. And then we need R&D on corrosive resistant membranes and durable, active, and cheap catalysts. And these challenges in terms of materials will be talked about in more detail by Dr. Indrat, I believe. He's been doing a lot of research in terms of materials for hydrogen. And you can also look at other methods. If you use SMR, then there are issues related to fission purification techniques. And then if we use coal gasification or biomass gasification, then we have a quite similar issue on the quality of hydrogen and about efficient purification techniques. And you can also see the opportunities as well as the present status for each of the methods in producing hydrogen. Now, how about Indonesia? Well, together with many countries in the world, Indonesia has acknowledged the need to incorporate hydrogen into energy systems. So there have been rules and regulations related to hydrogen, even though it's not special on hydrogen, but it's related to hydrogen. And now Indonesia is in the process of finishing its hydrogen roadmap. It has released its hydrogen strategy in December 2023, but the roadmap is still ongoing. But there are other institutions like this one. The roadmap are formulated by two agencies, Indonesia Fuel Cell and Hydrogen Energy over here, and also BRIN, which is the National Research and Innovation Agency. So they collaborate and produce this roadmap. And you can see on the left are all the sectors. You have power sectors, transportation, industrial, and also residential and buildings. And on the right side are all the actions or the strategies for immediate time frame, early adoptions, and then long-term time frame. And we can see, for example, transportation sector, immediate time frame, we have to do pilot project for hydrogen refueling station, which the government have conducted. We already have the hydrogen refueling stations in Jakarta. And then we also need to do light demonstrations of fuel cell vehicles, both motorcycles and passengers car. And then we need to move towards heavy duty trucks or heavy duty vehicles or industrial vehicles. And then long term to move towards more sophisticated transportation modes like ships, railway, and even aircraft. And you can also see all the strategies for different sectors. For example, in terms of industry, we need to produce or make small-scale demonstrations of green industries, and then how to turn hydrogen into green ammonia and then to export it in the long term. And the next one will be hydrogen projects in Indonesia. There have been a number of projects, mostly done by state-owned companies like PLN and Pertamina. And this is or are the notable 2023 hydrogen project announcements. The first one will be the Garuda Hidrogen Hijau, GH2, which is in Gresik, I think, East Java. And then we have Arun Green Hydrogen Plant in Aceh, and also the 21 green hydrogen plant owned by PLN. So these are the power plants, the 21 power plants that also produce green hydrogen. And also we have one project in East Indonesia, Bintuni Blue Ammonia or Blue Hydrogen projects. So there have been a number of projects, and there are more projects coming in Indonesia in terms of hydrogen. So last but not least, I would like to summarize my presentations that keeping global warming at 1.5 degrees Celsius above pre-industrial level is critical to avoid irreversible damages to the environment. And to achieve this target, then we have to decarbonize all sectors immediately. And to do this, hydrogen is crucial as energy carrier and also energy storage options. And currently, the majority of hydrogen in the world is gray hydrogen from natural gas, and in the future, it's been everyone's target to pursue green hydrogen. And Indonesia has acknowledged and understand the importance of hydrogen, and the government have released a number of rules and regulations related to it. And state-owned companies like PLN and Pertamina are also already involved in a number of hydrogen projects, like the coming one will be Garuda Hidrogen Hijau, DH2, and also Arun Green Hydrogen Plant in Aceh. With this, I would like to end my talk, and I think in more details about the materials for hydrogen will be given in detail by Dr. Indra. Mbak Iin, thank you for the time.